Okay, now let's look at question 5. The diagram shows the variation of the electric potential, V with a distance d along a straight line in a particular electric field. Okay, so we have electric potential V with a distance d. Okay, at which point is the magnitude of the electric field greatest? Okay, so now as you can see from the graph, okay, they have plotted V against D, right? V, okay, it shows the variation of V against D, okay? V against D. So now the question is, at which point A, B, C or D is the magnitude of the electric field greatest? So how do we relate electric field with V against D, right? That must be your question, okay? So if you look at your equations table, you will find this equation where E is equals to V over D, right? Now let's use a little bit of mathematics, okay? What this equation tells me is that the gradient of a V against D graph is the electric field. But how do you get that? Okay, so if you remember your y equals to mx plus c, m is actually your y over x, correct? So y over x is your gradient, your m. So y over x is your gradient, correct? That means, I say again, the gradient of a potential against distance graph is your electric field. This means at the point where there is the greatest gradient, is the greatest electric field. Okay? So now a lot of students might pick B or D because they are maximum and minimum points. But right, if you learn from your H2 or H1 mathematics, a maximum and minimum point actually have zero gradient, correct? Let me use my ruler here. If you can see, the gradient at B is 0 and the gradient at D is also 0, right? So therefore B and D cannot be the answers, even though they have, okay, let me say again, even though they have maximum and minimum points, B and D actually have gradient 0. At these 2 points, the gradient is 0. So what does it mean the gradient is 0? It means at the gradient is 0, the electric field at these 2 points must be 0. That is not what we are looking for. We are looking for where the electric field is greatest, okay? So now we have to look at A and C. So let's compare the gradient between A and C. For A, the gradient looks something like this, okay? This is the slope, the magnitude of the slope. But for C, the gradient is so much greater. You can see the slope is so much greater. If you have your book and your ruler, okay, I strongly advise you to go and try this out. So C has the greatest gradient, okay, compare of all the points. So if C has the greatest gradient, what does this mean? If you have the greatest gradient, that means your electric field is greatest. The magnitude of the electric field is greatest. C is the answer.